This is a molecule of hydrogen peroxide, H2O2. So we look this molecule from the front view, from the side view, and also from the top view, like this, or we can change like this. So what we can see that all atoms are not on the same plane, so this is not planar molecule. And then we look at the two-dimensional H2O2 structure. So we can see here thick bond between oxygen and hydrogen. It means that the hydrogen atom out of the plane. Oxygen and oxygen here on the same plane, but the hydrogen is out of the plane. So that's why we put the bond as a thick bond out of the plane. So now we are going to find out the symmetry elements operation for this molecule. When I look this molecule from the top view, I can see that these two hydrogen atoms opposite each other. So it means that we can rotate 180 degrees through the C2 axis. So we need to find out where is the C2 axis. So the axis must be here. The axis passing through the oxygen-oxygen bond here. So we try to rotate 180 degrees through this axis. We get the same configuration as before. Because the axis passing through the oxygen-oxygen bond, so we just label like a point here and label C2, and of course on the same axis we can rotate 360 degrees. And then we look at this molecule. What we can perform after this, we try to reflect this molecule. So we need to find out the plane for the reflection. Alright, so look from the top view. I try to put the plane cutting through the oxygen-oxygen bond here, and I can see that this hydrogen atom reflect through this plane. We don't get the same configuration. So we try to find another plane. So the plane cutting through here, or maybe we can change the view like this. So the plane cutting through here, and we can see that the hydrogen reflect through this plane, and again we don't get the same configuration. And then let's say this plane cutting through all oxygen atoms, and what we can see, this hydrogen atom reflect through this plane. The hydrogen atom will be reflect to the bottom, so we don't get the same configuration. So it means that this molecule has no plane for reflection. So symmetry elements operation for this molecule are identity C1 and C2. Last, we want to find out the point group for this molecule. So we can see that this molecule has C2 and C1. So our options are, the point group can be Cn or CnV or CnH or C infinity V. Alright, so our molecule is not linear. So that's why this is not the answer. And then this molecule has no plane. So we cannot choose this one and this one as well. So only this one. So this H2O2 has C1 and also C2 main axis. So that's why point group for this molecule is C2.